If gravity had been even slightly stronger, the universe would have collapsed under its own weight moments after it was born. And if it had been even slightly weaker, matter would never have gathered together. No stars, no planets, no us. But it's not just gravity. The strength of electromagnetism, the mass of the electron, the speed of light, all of these values appear to mesh together with almost unbelievable precision. Had several of the key constants taken significantly different values, carbon atoms would never have formed, DNA could never have assembled, and the being you call yourself would in all likelihood never have appeared in this universe. Is this coincidence? Or is there some deeper necessity at work? Or could it be the work of design? Scientists have wrestled with this question for decades. And in searching for an answer, a remarkable hypothesis emerged, one that cuts to the very nature of the universe itself. Today, we venture into the fine-tuning problem of the cosmos. By the time this video ends, you'll sense just how miraculous it is that you exist at all, and how the attempts to explain that miracle shake our understanding of the universe to its very foundations. Chapter 1. The Universe as a Precision Timepiece. Let's start with a simple question. Why do the laws of the universe take the form they do? The fact that you exist here, right now, depends on the universe operating in a very specific way. So how is that way of operating determined? Astrophysicists began asking this question in earnest in the 1970s and 80s. What they found was this: the conditions required for a universe to exist at all appear to be constrained to a strikingly narrow range. Consider what's known as the cosmological constant. This is the constant that governs the rate at which the universe expands. If it were too large, the universe would expand too fast for stars to form, too small, and gravity would crush everything back together. And when you compare the observed value to the naive theoretical estimate, what's called the Planck scale, the actual measurement comes out to roughly 1 part in 10 to the power of 120. Why it is so vanishingly small is an unsolved mystery in modern physics known as the cosmological constant problem. What does 1 in 10 to the 120th actually mean? The total number of protons and neutrons in the observable universe is estimated to be on the order of 10 to the 80th. The cosmological constant problem involves a precision that dwarfs even that number by an enormous margin. Nuclear physicist Fred Hoyle was studying the mechanism by which carbon is produced inside stars. His calculations revealed that unless carbon possessed an energy level positioned just above the fusion energy of helium, the production of carbon within stars would be almost negligible. That specific energy level is now called the Hoyle state. Hoyle was a figure who kept his distance from traditional religious theism. Yet after this discovery, he said something remarkable. The more I examine the universe, the stronger the sense grows that a super intellect has monkeyed with physics. This is the fine-tuning problem of the universe. The physical constants appear to be calibrated, as if by precise design, to the very values that make life possible. An important caveat, though. How strong the fine-tuning actually appears depends on which constants you vary independently, and how you treat the possibility that multiple constants might shift simultaneously. Here, we are already stepping across the boundary between science and philosophy. So how do we explain this extraordinary precision? In grappling with that question, we find ourselves at the edge of a philosophical abyss. But the real mystery is only just beginning. Scientists have proposed radically different approaches to answering this question. Let's dig deeper into what those explanatory frameworks actually look like. Chapter 2. The Anthropic Principle and the Temptation of the Multiverse. The first response to the fine-tuning problem was, in a sense, almost disarmingly simple. It's called the anthropic principle. Here's what the anthropic principle claims. The reason we can observe this universe is precisely because this universe has the properties that allow us to exist. If the universe had been different, we simply wouldn't be here. There would be no one to observe anything. At first glance, this seems logical. The fact that we exist necessarily means we inhabit a universe that permits our existence. It's like someone who wins a lottery being amazed they won. But if no one won, there would be no one to be amazed. The anthropic principle comes in two versions, weak and strong. The weak anthropic principle describes this selection effect. The strong anthropic principle has a range of definitions, but is often presented as the claim that the universe must have properties that permit the existence of observers. Whether that leads to a design argument depends heavily on interpretation. But many scientists felt the anthropic principle alone wasn't enough, because the anthropic principle doesn't actually explain anything. It merely confirms the fact that we are here. And this is where the multiverse hypothesis enters the picture. According to inflationary cosmology, the rapid expansion that triggered the Big Bang may have repeated itself many times over. The result, a vast number of universes, each with different physical constants, and we happen to inhabit one where life is possible. Combined with the anthropic principle, this seems at first like a complete answer to the fine-tuning problem. If countless universes exist, each with randomly assigned physical constants, then it's not at all surprising that one of them gave rise to life. String theory further proposes that under certain assumptions, through combinations of flux configurations and other factors, the number of possible vacuum solutions could reach something on the order of 10 to the 500th, a landscape of staggering proportions. With numbers that vast, it becomes statistically inevitable that at least one universe would be hospitable to life. And here's where I want to pause and think carefully. The other universes implied by eternal inflation are, in principle, extraordinarily difficult to observe directly. How to evaluate them as scientific hypotheses remains an active and unresolved debate. Does the multiverse solve the fine-tuning problem? Or does it merely relocate the question? Can we speak scientifically about universes we can never observe? This is a question that cuts to the very boundary between science and philosophy. And this question carries us somewhere even deeper. Let's consider what this hypothesis means at the level of human existence. Let's step back and look at what this question means for our existence in the broadest sense. Chapter 3. Coincidence, Necessity, or Design. The fine-tuning problem presents us with three candidate answers: coincidence, necessity, or design. This is a rare question, one where science, religion, and philosophy all intersect at once. Let's start with coincidence. If the multiverse hypothesis is correct, the physical constants we observe are simply a combination that happen to permit life, drawn from among countless possibilities. But the coincidence explanation has a problem. The multiverse, implied by eternal inflation, is extraordinarily difficult to verify directly. Whether it's legitimate to use something that is in principle unobservable as a scientific explanation is one of the central debates in contemporary physics and philosophy. Then there's necessity. Perhaps the physical constants of the universe are uniquely determined by a deeper law we have yet to discover. In other words, the universe takes this form because no other form was possible. If the physical constants carry an intrinsic necessity, the fine-tuning ceases to be a problem. But as of now, no theory exists that can explain why these values must be what they are. This answer is still waiting for the discovery of a deeper physical law, one we haven't found yet. And the third answer is design. If the universe appears so conveniently fine-tuned for life, perhaps someone designed it that way. This is known as intelligent design, a position that has sparked sustained debate at the boundary of theology and science. The main scientific objection to design is that it is unfalsifiable. Postulating the existence of a designer generates no new testable predictions. The criticism that it doesn't function as a scientific hypothesis is persistent and widespread. And yet here's where something catches my attention. Both the multiverse hypothesis and the design argument face the same criticism. Direct verification of either is extraordinarily difficult. We may be confronting a question to which science, in principle, cannot produce a definitive answer. Let's think about what this means. If science cannot in principle answer why the fundamental nature of the universe is what it is, does that represent a limit of science? Or does it mean this is simply a different kind of question altogether? The boundary between questions science can handle and questions that lie beyond it may be located right here. The fine-tuning of the universe demands humility from us. The reason we can exist is that the fundamental properties of the universe hold specific values. That fact alone is unshakable. Why those values? We still don't know. And I believe the very act of continuing to ask that question is itself a testament to humanity's intellectual honesty. And so we face a new question. What does it mean to keep asking questions without possessing the answers. Let's gather what this exploration has revealed. Chapter 4. New Questions About Reality. Today, we ventured deep into the fine-tuning problem of the universe. From the gravitational constant to the cosmological constant to the Hoyle state of carbon, the physical constants of the universe appear to be set with breathtaking precision to values that permit life. And when we ask why, we arrive at three candidate answers: coincidence, necessity, and design. Yet none of them has been fully proven. Let me bring together three insights from today's exploration. First, the physical constants of the universe appear to be set within the range that permits life to exist. The gravitational constant, the cosmological constant, the Hoyle state of carbon, had these values been significantly different, stars would not shine, carbon would not form, and we would in all likelihood not exist. Yet this assessment depends on the assumption of which constants are varied independently, and that assumption already contains a philosophical question within it. Second, the multiverse hypothesis is a compelling response to the fine-tuning problem, but it carries a fundamental difficulty. The other universes implied by eternal inflation are extraordinarily hard to verify directly. Whether the approach of postulating countless universes to transform coincidence into inevitability actually meets the conditions we expect of scientific explanation is a debate that continues to this day. Third, the fine-tuning question sits at the intersection of science, philosophy, and theology. The question of why these values, and not others, may be one that modern science is in principle unable to answer. And perhaps the act of holding that question with intellectual honesty is the very essence of inquiry itself. What these three insights reveal is this: the mysteries of the universe are not dissolved. They deepen, and in deepening, they lead us to more fundamental mysteries still. The further science advances, the sharper the outline of what we do not know becomes. Today's exploration has left me with one feeling, more than any other. The very fact that we exist is the product of a miraculous coincidence, or perhaps necessity, written into the physical conditions of the cosmos. The fact that you are watching this video, drawing breath, forming thoughts, behind all of it, physical constants set 13.8 billion years ago are quietly at work. When you truly grasp that precision, a sense of awe at the fact of existence rises naturally within you. Perhaps the universe is asking us something. Why is there something rather than nothing? And I believe the act of facing that question is itself the deepest expression of what it means to be a thinking being. I want to ask you something. If countless other universes exist, each with entirely different physical constants, does your existence hold any special meaning within this one? Or, in each of those universes, is some other form of intelligence asking its own, entirely different questions? And how do you face a question that science, in principle, cannot answer? The way you face it may itself be what shapes your entire worldview. I don't have an answer to these questions, and perhaps I never will. But I think that's all right, because continuing to ask questions without answers is the very depth of what it means to be human. After this video ends and you return to the rhythms of daily life, I hope you'll pause, just for a moment, and notice. When you look up at the night sky, the starlight reaching your eyes exists only because the physical constants of the universe are working with extraordinary precision. When you drink water, the atoms that form it exist only because the Hoyle state of carbon holds exactly the value it does. The fact that you are here, right now, is deeply connected to the fundamental nature of the universe. When you feel that connection, the cosmos stops being something distant. The mystery of the universe is your mystery too. We are observers studying the universe, but we are also beings the universe itself produced. In that duality, a profound question quietly dwells. I'd love for you to share your insights in the comments. Your questions are the force that drives this channel forward. Thank you for staying with me on this intellectual journey all the way to the end. The fine-tuning question stands at the boundary of science and philosophy, and the exploration continues. Here on Mindshift, we pursue questions like this, touching the nature of the cosmos, consciousness, and existence, with scientific rigor and philosophical depth. By subscribing to this channel, you join us on the journey toward the next question. If this exploration resonates with you, please subscribe and turn on notifications. Until next time.